Okay. So guys, today we are going to discuss about the STP production. Okay. So first of all, before start the STP production, first of all, you guys need to understand changes, or you can say types of changes. Basically, in STP, there are three types of changes. First one is called insignificant changes. What is guys? Insignificant changes. Second one is indirect change, and third one is direct change. Okay, so basically there are three types of changes. Okay, so when you guys will understand these are the changes, after that you guys are able to understand what port fast, uplink fast, and backbone fast. Basically these are nothing, these are basically make the STP more fast. Getting my point? That is, these are the feature. These are the feature. And to enable these feature, you can make STP more fast. Getting my point, everyone? If you guys remember, I told you, there are three types of switch, A, B, and C. Let's suppose this is the root bridge. This is the non-root bridge, right? Everyone. These are the non-root bridge. Clear? So these are the DP port. These are the DP port. This is the RP port. This is the RP port. This is the DP port, and this is the alternate port. I already remember these things right now. Everyone. For example, anyhow, this link goes down. What will happen? This block port will become. This block port will become in which state? Forwarding state. Yes, na? Yes or no? Everyone. Tell me. Yes, na? So when this will become in the forwarding state, again all the port role will decide. Again port role election will happen. Yes or no? Yes, na? Yes. Right now what is the state? Blocking state, or you can say alternate state. But now it is in which state? Forwarding state. So it must be either DP or RP. You know na, only DP port or RP port, both port state, forwarding state. Yes or no? Yes. So if this port will become in the forwarding state, definitely this port either will become the RP port or either become the DP port. What port it will become? This is your task. You guys need to find out the answer. Clear, everyone? But right now, sorry?
It will become DP.
This is your task. Okay, tomorrow I will ask you. Now,
okay,
it will become, guys, either DP or RP. But try to understand one thing. So when it become DP on RP, for example, if it become RP, then it is not possible here RP and here RP. Is it possible? No. Not possible. Everyone, yes or no? Yes, it is not possible. Then it will become what? DP? Yes or no? Yes, na?
Yes.
So if it will become DP, it will become RP on a single link. If this is switch 1 and this is switch 2, it will never happen. This is RP or this is RP. This is DP or this is DP. It is not possible on a single link. Both port will be same port role. It is not possible. Either one port will become the DP or either one port will become the RP. Getting my point, everyone?
Yes.
If it will become the DP, then definitely it will become the RP. What is happening? Port role is again deciding here. Yes or no? Yes, na?
Yes.
When anything is changed here, port role is again decide. Yes or no? Everyone? Yes. So if port role is again decide and see na, everything is happening again. So it means what is happening here? You can say convergence of your topology is happening here. What is happening, guys? Convergence of your topology, because everything is deciding again. Yes or no, everyone? Are tell me?
Yes.
Yes, na? So that is called convergence. Clear? And one more thing, this port is in which state, guys? Blocking state.
Blocking.
And when this link goes down, it come in which state? Forwarding state. And you know, by default from blocking state to forwarding state, which take how much time? 30 seconds? Yes or no? Yes. It means when this link goes down, this topology comes up, or you can say this topology completely converges after how much time? 30 seconds. It means you can say in a networking language, by default, what are the time, what are the outage? 30-second outage is there. Yes or no, everyone?
Yes.
Because this topology converges or this topology completely up after how much time? 30 seconds. Are you getting my point, everyone? So that
Yes.
is called convergence, or you can say that is called changes in topology. So whenever any changes will happen in the topology, definitely it will converge. Yes, na? Are you tell me?
Yes.
Let's suppose here this link goes down, then it will converge. Let's suppose if this link goes down, again it will converge. Yes or no, everyone? Yes. So definitely whenever any changes will happen, or any port or any link will goes down, definitely changes will happen in your topology, and that is called convergence of your topology. Getting my point? And in convergence, STP will take by default some time. Not every time it's 30 seconds. Getting my point? It takes some time more. I will tell you. There are different changes, and in different changes, time will be different. Getting my point, everyone? So
Yes.
for every types of changes, which will take the different time. But see, na, this is called outage. Yes or no? This is type of outage. So the question is, can we mitigate these type of convergence time or these type of outage? The answer is yes. We can mitigate this type of outage or convergence time. How? Basically, STP provide some feature. Again, I am telling STP provide some feature, and by enable these feature, we can mitigate these type of outage. Anyone who do not understand? It's clear to all of you?
Yes.
Name of feature is port fast, uplink fast, and backbone fast. Anyone who do not understand what are these three terms? These three terms are called feature of STP.
STP.
These are the feature of STP. And to enable, when you enable these feature in different changes, what you can do? You can mitigate the outage. Clear na? For example, if we have an insignificant change, here we enable one feature, in this changes, we enable different feature, and here we enable different feature. Are you getting my point, everyone? Yes or no? Yes, na?
Yes.
I hope now you guys understand changes. Clear, everyone?
Yes.
First of all, see here, insignificant changes. Insignificant changes. Let's suppose we have a switch, and you know, na, these are the access port, and through the access port, computers and printers are connected. Yes or no, everyone? Yes?
Yes.
Yes, na? So basically, when you connect any end device through this access port, by default, this port is in which state? Disable state. Which state? By default, it is in disable state. Yes or no, everyone? Yes. By default, it is in disable state. Are clear, everyone? So when you connect any PC, and even you can prove it in your packet tracer also, when you take the switch and when you connect any PC, it will take time. Na? Yes, yes or no? Yes, it
Yes.
takes time to come in the forwarding state. So basically, by default, this port is in which state? Disable state. And when you connect any device from disable state, it come in which state? Forwarding state. It move from disable to forwarding.
Forwarding.
And by default, it takes how much time?
30
30.
seconds.
Anyone who do not understand? Clear na? Everyone.
Yes.
So here, when we connect any devices, by default, it is taking how much time? 30 seconds. This is type of 30-second. You can say outage. Yes or no? This is
Yes.
30-second. Outage in real scenario. Generally, we cannot afford these type of outage. Yes or no? Everyone. Yes. In real environment, we cannot afford these things. Let's suppose if you are doing the practical, you guys can wait to come in the forwarding state, but in real scenario, we cannot. Getting my point, everyone? To mitigate these type of things, we enable one feature on this interface. The name of that feature is port fast.
Port fast.
What we enable, guys? Port fast. Clear, everyone? Are tell me.
Yes.
So when we enable the port fast feature on the access port, now switch will not wait for the 30 second.
Okay.
Clear, everyone?
Yes.
Yes.
I hope now you guys understand the port fast. Clear?
Yes.
Yes.
There is one more use of port fast, but this is not the part of CCNA, but I'm just asking. Anyone know what is the second use of port fast?
No.
Anyone? Nobody?
No.
At least tell me yes or no. Otherwise, I will.
No.
Okay.
No idea.
Guys, if you guys remember, I told you when I explain you the BPDU, there are how many types of BPDU? Two types of BPDU, right? First one is config BPDU and second one is TCN BPDU. Yes or no? Right
Yes.
now,
Yes.
in CCNA, we discuss about the config BPDU, right? Who is generating? Root bridge is generating after how much time? 2 seconds.
2 seconds.
Yes, everyone.
Yes.
I told you one line about the TCN also. TCN means topology change notification. Yes, na? I told
Yes.
you, na? Do not think only root bridge will generate the BPDU. Right? Non-root bridge also generate the BPDU. But which type of BPDU? TCN BPDU. Right? Whenever any changes will happen. Yes or no? Yes. For example, this is the switch. And again, let's suppose this is the switch number 2. Again, one switch is there and one switch is there. All the switches are connected like this. And this is the non-root bridge switch. Which switch, guys? Non-root bridge switch. For example, here PC number 1 is connected. But let's suppose after some time, this is laptop or this is the PC. This PC is removed here and another PC number 2 is connected. So this is the type of change. Yes or no? Everyone. Yes, na? Because on this port, this switch is now receiving the different MAC address. Yes or no? Yes.
Yes.
So now this is the type of changes. So what switch will do? Switch will start sending the TCN BPDU towards the root bridge. Yes or no? Basically, the use of TCN BPDU is, what is the use? Basically, non-root bridge inform about the changes to root bridge. Getting my point? So when the PC number 2 is connected, so this switch will generate the TCN BPDU to inform these changes about the root bridge. Getting my point? Yes or no?
Yeah.
Tell me yes or no? Yes, na?
Yes.
Yes.
But when you enable the port fast on this port never generate the TCN. I'm telling you why. For example, if you are working in the real scenario, this is the switch port, and let's suppose this is the desk. On this desk, one LAN port is there, and one end is connected with the switch. And let's suppose right now Ram came and connect his laptop here. Let's suppose after 30 minutes Sam came and connect his laptop here. After 30 minutes, let's suppose Mohan came and connect his laptop here. It is possible. Yes, this is common thing in the real scenario in the company. Yes or no? Yes, na?
Yes.
Yes.
One seat is used by different people. Yes or no? Yes. So if one seat is used by different people, it means this switch will generate what? TCN BPDU every time. Right na?
Yes.
So when this switch will generate the TCN BPDU every time, it will create the what? You can say loop, or you can say what? High bandwidth utilization will happen here. Yes or no? And this is the unnecessary TCN BPDU. Yes or no? Everyone. Yes.
Yes.
These are the unnecessary TCN BPDU. These are the end user. These are the end user. So end user never create the loop. Yes or no? Loop will create between the switches, not between the switch and end user. Are you getting my point? Yes or no?
Yes.
Between switch and end user, loop will not create. Loop will create between the switches. So is there any significance this switch will generate the TCN BPDU about these changes? No, there is no need. Are you getting my point? Yes or no?
Yes.
Yes.
There is no need. So that's the reason. What we will do, we will configure the port fast. So when we configure the port fast, what will happen? This port or this switch will not generate the TCN BPDU. So whenever any changes will happen on these port. Are you clear, everyone?
Yes.
Okay. Everyone, I hope you guys understand the port fast. Clear? Are you tell
Yes.
me? Now, this is called, guys, which type of changes? Insignificant changes. If we connect other switches, see, Nabil, actually, there are one more feature in the port fast. One feature I told you, it avoid the 30-second outage. Second, it avoid the TCN BPDU. Yes or no? Yes. So third, there is one more, you can say advantage, or these are the feature, or you can say this is the most important feature of the port fast. What? Let's suppose if this is the switch and this is the PC and this is port fast to enable. Let's suppose if anyone came with the switch and remove this PC and connect what? Connect one switch. So it means when this when it connect the switch, it generate the BPDU. Yes or no, everyone?
Yes.
If there is a PC do not generate the BPDU, but switch will generate the BPDU.
BPD.
So when the port on which you enable the port fast, when the port on which you enable the port fast, when on this port switch will receive any types of BPDU, what will happen? Immediately switch will convert or move this port in which state? You can understand like disable state, or how can I tell you so you guys can understand. But the actual rule is switch will lose port fast functionality. You can understand like this. Getting my point, everyone? Are you understand?
Yes.
So when any switches will connect and when any switches receive the BPDU here, immediately switch will lose the BPDU, sorry, port fast functionality.
Steps.
Clear, everyone? Then
Yes.
tell me. So this is the third feature. Nabil, I hope you understand. This is the advanced things for CCNP, but yes, you asked, so I answer your question. Clear, everyone? So this is called indirect topology. Now, guys, there are next type of changes is direct topology changes. So direct topology changes means, please write down one line. Whenever link directly connected to root goes down and switch has block port is called direct topology change. Try to understand what is the meaning of this one. For example, this is the switch 1, switch 2, switch 3. This is the root bridge. These are the non-root bridge. This is called DP. Yes or no? DP, RP, RP, DP, and block. Anyone? Any confusion? Clear now? So, I'm audible.
Yes.
Yes.
In direct topology, what will happen? What I write when the link goes down, and that link will be directly connected to the root bridge. It means, see na, these are the non-root bridge link. These are the non-root bridge. It's directly connected to the root bridge. This link, yes or no? Are these two links are directly connected with root bridge. Yes or no? Yes.
Yes.
It means among these two links, one link goes down. Yes or no? Are tell me.
Mhm.
Yes. Na?
Yes.
I also write one line. The switch which has which port? Block port. So tell me, switch number 2 and switch number 3. Which switch has the block port? Switch number 3. So it means this link goes down. Are you getting my point? Yes or no? So this is called which type of change? Direct topology change. Anyone who do not understand direct topology change? Are tell me, yes or no? Understand na? So
Can you?
when this, anyone asking something?
Yes, sir.
Are you asking something? Okay. So if this link goes down, what will happen, guys? This port will come in which state? Forwarding state. Right now, in which state? Blocking state. Yes or no? Everyone, tell me.
Yes.
Right now, this is in which state? Blocking state. But when this link goes down, it will move in which state? Forwarding state. So from blocking state to forwarding state, it takes how much time?
30 seconds.
30 seconds. Or you can say this is the 30-second outage. Yes or no?
Yes.
Are tell me yes or no? Yes, na? Everyone.
Yes.
So that is called which type of change, guys? Direct topology.
Topology.
Change.
Clear? Everyone.
Yes.
Yes.
So to avoid these type of outages, we have a different concept. What is the name? Everyone. That is called
Port fast.
what? Tell me. Yes. Uplink fast. What we enable, guys? Uplink fast. Are clear, everyone? Yes or no?
Yes.
Okay.
That is called direct topology change. I hope you guys understand the direct topology change and uplink fast. Understand, everyone?
Yes.
Now, again, next change called which change? Direct topology. Sorry,
Indirect.
right now we discussed what? Indirect topology change, right? Sorry, direct topology change. So next one is, guys, indirect topology change. So indirect topology change, nothing will happen. See, A, B, C. Here in this change, what will happen? This port goes down or this link goes down. It means the link that is directly connected with the root bridge. Again, I am telling what is the definition? The link that is directly connected with the root bridge and which do not have block port. Getting my point? That type of change is called indirect topology changes. Understand, na? But in direct topology changes, what will happen? The link that is directly connected with the root bridge but has block port. That is called direct topology changes. Are you understand, na, everyone? Yes or no? When
Yes.
this link goes down, it means this is called direct topology changes. Yes or no, everyone? Yes, na?
Yes.
And when this link goes down, then it is called indirect topology change. Are you clear? Yes or no, everyone?
Yes.
Now see what will happen. So when this link goes down, it do not have any block port. Yes or no? Are you
Yes.
tell me? Right, na? This is the DP. This is the DP. It was RP, DP, and block. Yes or no, everyone?
Yes.
Yes. See now,
Yes.
when this port goes down, it do not have any alternate port. Understand? So what will happen when this port goes down? It means this switch lose the connectivity with the root bridge. Yes or no? Yes, na? Are this switch was connecting with the root bridge through this link, but this link goes down. It means this switch now lose the connectivity with the root bridge. Are yes or no? Yes, na? Because this is the which port? Block port. Right, na? So through this port they cannot reach, na? Yes or no? Are tell me.
Yes.
Yes, na? Through this port switch number B cannot reach. It means switch number B, you can say, lose the connectivity with root bridge. Are you understand? Yes or no? Yes.
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 So when this link goes down, what switch number B will do? Switch number B will think I am the root.
Bridge.
I am the root bridge. And switch number B start sending the what? BPDU here through this link. Getting my point, everyone? But
Yes.
switch number C already receiving the better BPDU through this link, because for switch number C, who is the root bridge? A is the root bridge. Right, na? Switch number C is receiving the BPDU on this interface, right na everyone? Yes or no? And this BPDU is better BPDU. Are yes or no? Yes.
Yes.
When switch number C receive the BPDU on this port, switch number C will tell switch number B, bro, actually I am already receiving the better BPDU on this port. If you are telling you are the root bridge, let me think about it. Let me think about it. Because on every interface, you know, na, for every interface, there is a buffer memory. Yes, na, everyone? For every interface, there is some memory. Whenever switch will receive or any device will receive any packet, that packet is stored where? In buffer memory. Understand, everyone? So
Yes.
when this switch will receive this BPDU here, this switch is telling to switch number B, bro, I am already getting the better BPDU on this port. If you are telling you are the root bridge, let me think about it. So what you have to do? You have to wait in my buffer memory. In my buffer memory. But again, how much time? 20 seconds. How much time, guys? 20 seconds. And that is called maximum age time. You saw now when I write the command, if you guys remember. So spanning tree VLAN 1. When I write this command, you saw now there is one more time that is called maximum age time. Are yes or no? Yes, na?
Yes.
That is 20 seconds. 20 seconds means whenever switch number C will receive the better BPDU, getting my point, on any other interface, switch number C will wait how much time? 20 seconds. After 20 seconds, switch number C will start compare this BPDU and this BPDU which switch number C is getting here. Are you getting my point, everyone? Yes or no?
Yes.
Understand? So first of all, switch number C wait how much time, guys? 20 seconds. Now after 20 seconds, switch number C again compare what? Both BPDU. Now switch number C find on this interface what is the root bridge ID? 32768 plus B. Yes, na, because B is sending. Yes, na,
Yes.
everyone? And on this interface, switch number C is receiving 32768 plus A. Which one is better? This is better. Yes or no?
Yes.
Yes. Now switch number C will tell to switch number B, bro, actually you are telling you are the root bridge, but no, I am receiving the better BPDU. Here, फालतू का तुमने time pass कर दिया. Yes or no, everyone? Yes.
Yes.
Switch number C will tell I am still receiving the better BPDU on this interface. So switch number C still consider switch number A as the root bridge. Switch number C do not accept switch number B as the root bridge. Getting my point, everyone? Yes or no? Yes.
Yes.
Now switch number B also realize I am not the root bridge because switch number C is getting the better BPDU than me? Yes or no? Yes. Now switch number C is receiving the BPDU, better BPDU here. Now what switch number C will do? Switch number C forward this BPDU towards switch number C. Are you getting my point? Yes or no? Everyone.
Yes.
Switch number C is receiving the better BPDU from A. Now switch number C will forward this BPDU towards B. Now here two things. Please think here, guys. First, switch number C forward this BPDU towards switch number B. It means this port will be in which state? Forwarding state.
Forwarding.
And switch number C will forward it. Yes or no? Yes? Can you tell me? Yes, na? But before this port was in which state? Blocking state. Yes or no? Yes.
Yes.
But now this switch number C is forwarding this BPDU, which switch number C received from A through this interface. It means this port is in which state? Forwarding state.
Forwarding
It means
state.
it takes how much time? 30
30
seconds.
seconds.
Right, na? Are from blocking to forwarding, how much time? 30.
30 seconds.
So this is the first thing. Second thing, when any switch is sent the better BPDU through any interface, that port will become root port or DP port. DP port.
DP port.
Right? Na? DP port means what? I told you in yesterday class. DP port means the port through which switch is sending the better BPDU. Yes or no? So switch number C is sending the BPDU here through this interface. It means this port is called DP port. Right? Everyone? Yes or no? Yes?
Yes.
Yes, sir.
And I will tell you the answer of your homework question also. I hope you guys understand it. Clear? Everyone. So that is
Yes.
called DP port. And on this port, switch number B receive the better BPDU. Yes or no? Yes, na?
Yes.
On
Yes.
this switch number B is receiving the better BPDU. It means this port will become which port?
Root.
RP.
So now tell me how much, what is the outage here? First switch wait how much time? 20 seconds.
20
After
seconds.
20 seconds, this port move in blocking to forwarding. It means how much time again?
Forwarding.
30.
30 seconds.
Total outage is
30.
20 plus 30. How much?
50 seconds.
50 seconds.
3 seconds. So to avoid these type of outage, again we have another feature that is called back. What is? What I told you?
Backbone first.
Backbone.
Fast.
I hope you guys understand all the feature and all the topology. Clear? Everyone. Anyone who do not understand, it's clear to all of you?
Yes.
Correct.
Yes.
These are not part of CCNA, but yes, I explained you these things, guys. I hope you guys understand it. Clear? Everyone.
Yes. Got it.
Okay. I already mentioned the command by which you can enable the uplink fast, backbone fast. Let me show you. I hope it's visible to all of you. So this
Yes.
is the port fast. So basically, these are the command for port fast. Okay. So I told you where we enable the port fast on the access port only. Okay, everyone.
Yes.
Here on access port where end users are connected. So interface fast is an 0x1, and here you have to write spanning tree port fast. Okay. So by this command you can enable the port fast, and these are the command you can verify. So spanning tree summary you guys can get. Okay. I don't know in packet tracer it will work or not, but you guys can try. So spanning tree, then you can write the interface fast is an 0x1 and write the port fast. Getting my point? So this is the also command you can verify it. Are you understand everyone? Yes or no? Now
Yes.
next one is uplink fast. So command is uplink fast. We are not enable on interface. We are enable on globally. Okay, na? So go in the global configuration mode and write down the spanning tree.
Spanning tree uplink.
Fast. And this is the command to verify it. So spanning tree uplink fast. The next one is backbone fast. What is the command? Spanning tree backbone fast.
So
Clear?
if you run this command spanning tree backbone fast, it will not.
Yes, it avoid the 50 second. It means generally backbone fast, the use of backbone fast it do not wait for that 20 seconds, or you can say backbone fast mitigate the maximum edge time 20 seconds. Okay. Are you understand? Yes or no?
Yes, yes. Understood.
Okay. Now the next term is STP protection. What? STP protection. In STP protection, I told you how much terms, guys? Root guard, loop guard, BPDU guard, and BPDU filtering. Yes, na everyone? Yes or no?
Yes.
Yes.
You guys confused or not? I have lots of confusion. All are guard. Root guard, loop guard, BPDU guard. I don't know which guard is applied. Okay, no problem. First of all, we will discuss, guys, root.
God.
When you see the name, what you guys are feeling? Root means root bridge, guard means guarding. It means definitely this feature guard our or protect our root bridge. Yes or no? Everyone. Are you telling me?
Yes. Yes.
Yes. If you are thinking this, it means you guys are correct. This feature protect our root bridge. Getting my point, everyone? Now, one more thing. In yesterday class, if you guys remember, I told you my scenario where I told you, see, this is my core switch, or you can say core layer, and this is the distribution layer, and these are the access switch, and here end users are connected. Yes or no? I told you, na?
Yes. Yes.
Yes, na? So I told you there are basically two, I have in my company also there are two DR1 and DR2, right? And generally we make these two DR as the root base, always. Yes or no? Yes?
Yes.
It means both DR is the root bridge. Are yes, na? These are the core switch and these switches are root bridge generally. And in maximum company, you guys see these type of thing. Clear? Everyone? Yes or no? Yes? Now the thing is, basically we implement the root guard to protect these root bridge. Yes or no? Yes? Everyone? Yes,
Yes.
na? But try to understand one thing. Root guard feature we are not enabling on root bridge switch or root bridge device. It means we are not enabling these feature here, or you can say on core layer. Are you understand, everyone? Or you can say root guard feature we are not configuring root guard feature on root bridge. Getting my point, everyone? So on root bridge we are not configuring. So where we are configuring? We configure the root guard feature on distribution layer. What, guys? Where, guys? Distribution. Understand? So if anyone asks you, tell me something about the root guard, what you guys can answer? You guys can answer root guard is the feature which is applied or implement or enabled on which layer? Distribution layer to protect our root bridge. Yes or no, everyone?
Yes.
Yes. So this is the first definition. Now, if anyone asks you one more thing, tell me why we are using the root guard feature. What will be your answer? To protect the root bridge. Again, interviewer will ask you to whom you are protecting. Is there any ghost or something is happening here to capture these things? No. To whom you are protecting the root bridge? आप root bridge को किस चीज से बचा रहे हो? The point is we are protecting the root bridge. What? For what? Basically, we enable the root bridge to avoid any other switches will become the root, or you can say access layer switch will become the root bridge. Getting my point? So we do not want our access layer switch will become the root bridge, because we know the responsibility of root bridge is quite much. Yes or no? Yes. because it is generating the BPDU after every 2 seconds. It is taking all the topology changes right now, everyone. Yes or no? Yes. So
Yes.
there are lots of load on root brace. So what we want? We want our strongest device should become the root brace. Yes or no? Yes.
Yes.
And what are the criteria to become the root brace? On the basis of brace ID? Are tell me yes or no? Yes, na?
Yes.
Example, let's suppose this is my Nexus device. This is my Nexus device. This is the new Nexus device. For example, the MAC address is, let's suppose 32768 plus, this is a Nexus one, it means latest. So let's suppose 0x. So this is the latest one. But for example, this is the access layer switch, and this is the very old switch. This is the very old switch. So you know na, if this is the old switch, it means it has the very lower MAC address. Yes or no? Yes, old switches have lower MAC address. Getting my point, everyone? Are you tell me? Understand?
Yes.
So you know na, if I don't know you guys are know or not, let's suppose if your any computer, laptop or mobile phone is damaged, or you can say in a scrap. So basically company purchase your scrap thing. If you are working in your company also, if you are in the desktop support, you guys know there are lots of computer and PC which are the part of scrap. Then the company or vendor purchase it. Yes or no? Yes, na?
Yes.
Basically Dell or Lenovo purchase these devices. Why? Basically na, they use the MAC address, guys. They use the MAC address which is inserted on an IC card. Similarly, in case of Cisco device also. Are you getting my point, everyone? So for example, this is the old device, and here MAC address is 0A. So 32768 plus 0A. Now tell me, na, this is the Nexus and this is the old device. Which will become the root base? Obviously, this will become the root base. Yes or no? Yes.
Yes.
But we do not want. Are you tell me? Yes, na? We do not want our
Yes.
old device will become the root base. Otherwise, how this device will handle the all the parameters or all the things here in my network? This is not possible. Getting my point, everyone? So to avoid access layers which will become the root base, we have a concept or we have a feature called root guard. Are you getting my point, everyone? Yes or no? Yes.
Yes.
So we enable the root guard feature where? On distribution layer. Clear? Everyone, tell me. Understand?
Yes.
We enable this feature where, guys? Access layer switches. For example, switch 1, switch 2, switch 3, and switch 4. Let's suppose this is the topology. Obviously, this is the core layer. This is the distribution layer, and this is the access layer. Yes or no?
Access layer.
Everyone. Yes, na?
Yes.
And this is our root base. So we will configure the root guard where? Here. We configure the root guard here. Yes or no? Everyone.
Yes.
Yes, na? So
Yes.
basically when we configure the root guard here on switch number 2 and switch number 3, what it will do? Basically, it will try to avoid switch number 4 will become the root base. Are yes or no? Yes, na? It
Yes.
protect to become switch number 4 will become the root base. Are yes or no? Yes, na?
Yes, sir.
Getting my point, everyone?
Understood.
Okay. I understand, everyone. Anyone who do not understand, it's clear to all of you. So basically, when we enable the root guard, what root guard will do? Root guard will protect switch number 4 to become the root bridge. Because who is the root bridge in your network? This one, core layer, switch number 1. Are yes, na, everyone?
Yes.
For example, here I change the priority, or here I lower the priority. So when you lower the priority, definitely it will become the root base. By default priority is 32768. Yes or no? Yes, na?
Yes.
I
Yes.
told you the lower priority will prefer. So let's suppose I change the priority on switch number 4 and I change the priority lower. So switch number 4 announce itself as a root bridge now because its priority is lower. Are yes, yes, na?
Yes.
It starts sending the BPDU through this interface and through this interface. Are yes or no?
Yes.
Yes. Now what will happen? Okay. See here. First of all, tell me one thing. Let me clear your confusion. Let's suppose this is the by default topology. Okay, this is the root bridge. Nothing is happened. Now tell me the port role. This will become the DP, DP, RP, RP. This is the DP, DP. This port become the RP and this port will become the block. This is the basic thing, na everyone? In yesterday class we
Yes.
discussed. Yes.
Yes.
Let's suppose on switch number 4, I change the priority and priority is lower. Switch number 4 announce itself as a root bridge.
Root bridge.
Now switch number 4 starts sending the BPDU through this interface and this through the interface. Yes or no? Yes? Tell
Yes.
me. Yes, na? So this interface, this is the RP port, now become the DP. This is the blocking port, now become the DP. Yes or no?
DP.
Yes, because you know na every port of root bridge is called DP port.
DP.
So this is the DP, this is the DP. Switch number 4 is sending the BPDU here and here. Now tell me one thing. Switch number 2 and switch number 3 receive the BPDU here and here. Yes or no?
Yes.
Yes. But actually what is the definition of DP port? On DP port, switch will send the BPDU only. Yes, na everyone? But
Yes.
here, switch number 2 and switch number 3 start receiving the BPDU here. Are tell me, yes, na everyone?
Yes.
So when switch number 2 and switch number 3 start receiving the BPDU here from switch number 4, then switch number 2 and switch number 3 open this BPDU and compare. I am getting one BPDU here and I am getting one BPDU here. Which BPDU is better? Are you getting my point, everyone? Yes or no? So when
Yes.
switch number 2 find this BPDU is better, so switch number 2 consider switch number 4 is the root bridge. Are yes or no? Yes, na? I am
Yes.
telling you before the implement of root guard
Root
feature.
guard.
Understand?
Yes.
Everyone.
Yes.
But we do not want these things. Yes or no? Everyone.
Yes.
And na? So what we will do? These are our non-root bridge. Are you understand na? And these are our access layer switch. So we configure what here? Root guard feature.
Root guard feature.
Root guard feature. So what root guard feature will do? Basically, when the distribution layer switch will receive the any BPDU on any which port? DP port. Any DP port. Are you getting my point? Everyone.
Yes.
Understand? From where? From? Tell me. From any
Access layers.
Yes. Layer.
any access layer switch. Understand, everyone?
Yes.
Okay. And if this BPDU is better than existing root bridge BPDU, understand, everyone?
Yes.
Are switch number 2 receive the BPDU here and switch number 3 receive the BPDU here. It means switch number 1 is the existing root bridge, right na? For switch number 2 and switch number 3. It means switch number 2 and switch number 3 already have BPDU or existing BPDU of this one. Yes or no? Yes.
Yes.
And if switch number 2 receive any other BPDU other than existing BPDU on any DP port, so when you configure the root bridge, immediately switch number 2 and switch number 3 move these two ports in which state? You can say root inconsistent state, or you can say blocking state. Understand? So this is the feature of root guard.
Root guard.
Basically through this port, these switch do not forward any data. Understand everyone? I hope you guys understand. Clear? Tell me.
Yes, sir.
So that is called root guard. So the question is where we enable the root guard? We enable the root guard on our distribution layer switches. Next thing, what is the use of root guard? To protect our
Good.
existing root guard, right? Sorry, a root base. Yes, na? To
Yes.
protect our existing root base. Now, if anyone asks you how root guard will work, how can you answer? You guys can answer when any distribution layer switch receive the any better BPDU on any DP port, any better BPDU compared to existing BPDU on any DP port, immediately distribution layer switch move all the DP port in which state? Root inconsistent state, or you can say the blocking state. Clear, everyone? Clear na?
Yes, sir. Will it block all the frames also?
All the
All traffic?
yes, it will in the block state. It means there is no packet flow here. And interviewer can ask you one more question here. Actually, how you can recover from the root inconsistent mode. So what you can answer? You can say we can recover from root inconsistent mode automatically when this access layer switch stops sending the BPDU. I understand everyone. When this switch stops sending the BPDU. Are clear everyone? So as a network engineer, when you get this type of thing, this port is in root inconsistent state. Understand everyone? So generally, you are not running the no shutdown command, because if you are running the no shutdown command, it means you are in the risk. Yes or no? Yes, you are risk. So generally, we are not doing these type of thing in our troubleshooting session. So what we are doing, guys, we are checking the root cause. What? Root cause. This port is becoming the root inconsistent. So what we will check? We will check the connected device through this interface. So this device is connected. So we will check the functionality of this switch or behavior of this switch. Getting my point, everyone? To solve these problems. Are you getting my point, everyone? Understand now?
Yes.
Yes.
Now the thing is how we enable the root guard. For example, this is the fast Ethernet 0x0. First of all, you have to go interface fast Ethernet 0x1 and you have to write which command? Spanning tree. Command is guard root. What is the command? Not root guard, guard root. What is guard root? Clear, everyone? I hope you guys understand.
Yes, sir.
That is all about the root guard. The next one is, guys, loop guard.
Good God.
What do you mean by loop guard?
Protecting the loop.
Okay, you are telling protecting the loop. Okay. Anyone? Okay. See here, guys. Basically, loop guard is something related to the root guard feature. Okay. Just recap the root guard one thing, everyone. Then I will explain you what is how you guys can understand the loop guard also. Basically, in root guard, what you guys are doing on basically on distribution layer switch. On distribution layer switch, and where? On DP port. Right now, on DP port, generally you are enabling the root guard. Yes or no? You enable the root guard feature on the DP port, on the distribution layer switch. Yes or no? Guys, yes or no? Arey, forget you guys. Switch 1, switch 2, switch 3, switch 4. This is the DP, DP. Arey, RP, RP. This is the DP, this is the DP. This is the RP and this is the block. Anyone? Any doubt? Where you configure the root guard? Here, na?
Yes, sir. Yes, sir.
Yes.
Here you configure the root guard. Here you configure the root guard. It means you configure the root guard on which port? DP port of distribution layer. Yes or no?
Yes, sir.
Everyone, why you guys are so silent?
Yes.
It means we can say in root guard, you are protecting your DP port. Yes or no? In root guard, generally you are protecting your DP port because you are configuring these things on the DP port and you do not want this port will become the RP port. Yes, na? If this port will become the RP port, then it means you are considering this switch as a root bridge. Yes or no? Yes, na? But we do not want to consider this switch as a root bridge. So if you consider this switch as a root bridge, it will send the BPDU. And if your switch receive the BPDU here on this port, it means this port will become the RP port. And we do not want these things. So that's the reason what we are doing. We enable the root guard to protect our DP port. Anyone who do not understand? Clear?
Yes.
Tell me. Yes, na?
Yes, sir.
So basically in root guard, what you are doing, you are just protecting your DP port. You are just protecting your DP port. Understand? I hope it's clear to all of you.
Yes.
Okay. Now come on the loop guard. So this feature is enabled on non-DP ports. Where we enable this feature, guys? Non-DP ports. Non-DP ports means either RP port or either
Block.
RP port or either block port. I understand, everyone. Now you can say your root guard feature is protecting your which port, guys? DP port. Your root guard feature protecting your DP port, na? Everyone.
Yes.
And your loop guard feature protecting your non-DP,
Oops.
either RP port or either block port.
Block.
Anyone who do not understand? It's clear to all of you? Tell me.
Yes.
That is called loop guard. Clear, everyone?
Yes.
Now, I can give you one example. If you want, I can give you the loop guard example. See, then maybe then you guys will understand in a better way. For example, this is the switch number 1, switch number 2, switch number 3. Let's suppose if this type of topology we have. Again, this is the root bridge and these are the non-root. Understand, na, everyone? This is the DP port, DP port. This is the RP, RP, DP block. Understand, everyone? Yes or no?
Yes.
Okay. Switch number, I told you na, on the blocking port, switch also receiving the BPDU. Yes or no? Yes, na?
Yes.
On blocking port, switch also receiving the BPDU. If switch stops receiving the BPDU on blocking port, then this switch will consider this device is dead. Yes or no? Yes, na, everyone? Are you understand? I told you these things. Tell me.
Yes, sir.
Think like this. This is the switch. This is the port. Let's suppose here PC is connected. So tell me one thing. Is switch assuming or expecting any BPDU on this interface? No.
No.
Because here which device is connected? PC is
PC.
connected and the device is connected. So on this port, switch is not expecting any BPDU. Yes or no? So that's the
Yes.
reason this port is in which state? Always forwarding
Visible.
state. Always which state? Forwarding state. Are you getting my point, everyone? Understand?
Yes.
Huh? But if this is the switch and if this is the switch number 2, here switch can assume the what? BPDU. Switch can expect the BPDU. So we cannot say this port always be in forwarding state. Are you understand? Na? Role will be different. Maybe DP port, RV port, or maybe blocking port. Yes or no? Everyone. Understand? Try to understand what I'm trying to say. Everyone. Similarly, let's suppose if this is the switch number 3, switch number 3 is receiving the BPDU here. Understand? It means switch number 3 is expecting here what is connected. Switch is connected. That's the reason I am receiving the BPDU here. So that's the reason switch move this port in which state? Blocking state to avoid the loop, and this is the called STP. Yes or no? Everyone. Yes.
Yes.
But let's suppose if switch number 3 is not receiving the BPDU on this interface. Reason is anything XYZ. Getting my point? Reason is anything. But if switch is not receiving the BPDU here, it means now your switch number 3 assume if I am not receiving the BPDU here, it means definitely here who is connected? Any end user is connected. Who is connected? Any end user is connected. And immediately switch number 3 move this port in which state? Forwarding state. Now think, I told you previously DP port and RP port both are always in the forwarding state. Yes or no? Yes.
Yes.
This is forwarding, this is forwarding, 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 forwarding. And now this port also in forwarding. What will happen? Loop will create. What will happen? Loop will create because your packet will go through every link. Are yes or no? Yes, na? Same I saw you when I disable the STP. Are yes or no? Yes, na? This is the use of STP. What is the use of STP? When you configure the STP, if you have a redundant path to reach the destination, if you have a 2 or more path to reach the destination, what STP is doing? STP just block the one port and choose the best path to reach the destination. And when that path will goes down, then other path automatically comes up. This is the use of STP. Are you tell me yes or no? Yes. But
Yes.
here, let's suppose I do not disable the STP. I do not disable the STP, and this port comes in the forwarding state. It means what will happen? Again, loop will create. I hope you guys understand. Because all the port is in which state? Forwarding state. It means your packet will go through every link. Are yes or no? Yes, na?
Yes.
So that is also called
Yes.
loop. Your topology will go in looping state. Clear? Everyone.
Yes.
Yes.
Now, again, your question, sir, you are telling this port is in the which state? Blocking state. If
Blocking
STP is there. Yes. And switch
Yes.
number 3, switch number 3 is receiving the BPDU, and this port in the blocking state. My question is till when? Is there any time frame, or till when this port will become in the blocking state, or till when this port is in the blocking state? What is the answer? Answer is this port is in the blocking state until this port receive the BPDU. Are you understand? Na? When this switch stop receiving the BPDU on this interface, immediately switch number 3 starts thinking who is connected on this interface, and the device is connected. And immediately switch number 3 will move this port in which state? Forwarding state. Are you clear, everyone?
Yes.
Are you clear, everyone? Anyone who do not understand? Clear now? Okay.
Yes.
In an interview, an interviewer asked one question, tell me,
Hello.
Hello.
बंद कर दो लाइट जल मोटिंग ना लाइट
Power cut. Power cut.
I'm audible.
Yes, sir.
Okay.
yes
Sorry guys for the power cut. Okay, so what we are discussing that time, what I told you, anyone? Yes, I got it. So if any interviewer asks you, ki just tell me one thing, you are telling ki this port is called the blocking port and this port is called the RP port. Yes or no? Yes. Yes, na?
Yes.
Are yes, na everyone? But how? Why? Why this port is the blocking port and why this port is the RP port? Your answer is, very simple answer. This port will become the RP port. Why? Because on this port, this switch receive the better BPDU. And on this port, switch receive the inferior. So basically, there are two types of BPDU, superior or inferior. So on this port, switch receive the superior BPDU. So that's the reason this port become the RP port. And on this port, switch receive the inferior BPDU. So that's the reason this port become the block port. Yes, na everyone? Yes or no?
Yes.
Clear na everyone? So I hope now you guys understand. See, actually, when you do not configure the loop guard, and let's suppose if anyhow or any reason, let's suppose this switch number 3 is not receiving the BPDU on this interface. What switch number 3 will think? Switch number 3 will think on this interface who is connected? End user is connected. Understand? And this PC, switch number 3, move this port in which state?
Forwarding mode.
Forwarding.
Forwarding.
And which port? Port role will be DP port. Remember, this port always be which port? DP port. Where your end user is connected, this port always be DP port. So this port always become the DP port. Now think na, on this link, this is also DP and this is also DP. Is it possible?
No.
No, na, I told you na. If this is the switch 1 and this is the switch number 2. So DP, DP, it is not possible. Switch number 1, switch number 2, RP, RP, not possible. So if you are getting on the same link DP and DP, what will happen? Loop will create. What will create, guys? Loop will create. And to avoid these loop, we have a concept of loop guard. So that's the reason I told you where we configure the loop guard on the, tell me, on the non-DP. Non-DP port means either on the block port or either on the RP port. So this is the which port? Block port, na? Everyone.
Yes.
This is the block port. So here we configure what? Loop guard. I hope you guys understand. Everyone clear na? Tell me.
Yes, sir.
Okay. So actually when you configure the loop guard here, now the thing is how switch number 3 will behave. How switch number 3 will behave. Understand, everyone? Anyone? Any answer? See, let's suppose I told you na, if switch number 3 is not receive any the BPDU on this interface, the reason is any XYZ, maybe the link failure or the link is slow or anything. There is multiple reasons. Switch number 3 do not receive the BPDU, then switch number 3 will think who is connected, end user is connected, and immediately this port will become the DP port. So on DP and DP it will create loop. So to avoid these loop, we are configuring the loop guard. Clear? Now,
Yes.
suppose if switch number 3 do not receive any BPDU here on this interface, it means what is happening? BPDU miss. What happened? BPDU miss na? Yes or no?
Yes.
Yes. So when to configure the loop guard and when switch number 3 miss any loop, BPDU here, immediately switch number 3 move this port in which state? Loop inconsistent state. Which one? Loop inconsistent state. Understand? Which one? Loop inconsistent state. So either you can say loop inconsistent state or either you can say block state. Blocking. This is already blocking. Yes, na? Everyone.
Yes.
So which will move this port as a loop inconsistent, or you can say the blocking state. And this is type of manual protection. This is type of manual protection. Clear? Everyone. Tell me.
Yes, sir.
So this is the way how loop guard will work or behave. Clear? Everyone. Tell me yes or no.
Yes, sir.
Now the next one is called BPDU guard. BPDU guard is so simple. Nabil asked that time one question. Question was, this is the switch, this is the PC, and Nabil asked, let's suppose if here we configure the port fast, right now everyone? Yes or no?
Yes.
Yes. But right now forget the port fast. Now think, let's suppose if anyone came with the switch. Anyone came with the switch and connect here. It means this is the access port and this switch receive the BPDU here. It means this switch is not expecting the BPDU here on this interface. Yes or no? Yes.
Yes.
This on access port generally switch is not expecting any BPDU, but here switch is receiving the BPDU. So here to protect these things, what we configure? BPDU guard. What we configure? BPDU. Clear, everyone? So if anyone asks you what is the use of BPDU card, what is your answer? To protect our access port. When our access port receives the BPDU, it means through the access port any switches is connected. And this is not good. Basically through the access port, only end users are connected. Are yes, na everyone? Yes. So if any switches is connected, it means there is a chance to create a loop. Yes or no? Right, na?
Yes.
Arey, if this is the switch and if this is the PC, so if end user is connected, there is no chance to create the loop. Yes or no? But if you connect
Yes.
the switch here, there is a 100% chance to create the loop. Yes, na everyone? To avoid these things, we have a concept of what? BPDU.
Loop.
Understand, everyone? Are tell me.
Yes.
So now the question is, sir, let's suppose if this is the switch and if any user came with the switch and connect, and here you configure the BPDU, what will happen? So guys, when you configure the BPDU and when this switch will receive any BPDU on this interface, immediately switch will move this port in which state? Error disable state. Error disable state. Now the question is, how can we recover? So you have to run SUT or no SUT. What you have to do? You have to SUT or no SUT this interface, then it will, you can recover it. Are you understand, everyone? Yes or no? But again, tell me, is this the best way? No. This is the not best way. But in real scenario, if you are getting these type of thing, if you are getting any incident tickets related, any port will go in the error disable mode. What you have to do? You have to check the root cause, guys. Why? Are you getting my point, everyone? Yes or no? Understand? Now, for example, if anyone asks, tell me one thing, this port go in the error disable, you write SUT or no SUT. After 10 minutes again, it go in that error disable again, you write SUT or no SUT. Now the thing is, how many times you guys write the SUT or no SUT? Is it viable? Answer is no. It is not viable. So that's the reason we have a different concept that is called BPDU filtering. What? BPDU filtering. What BPDU filtering will do? So when you enable the BPDU filtering, what BPDU filtering will do? Anyone? Any idea? So when you enable the BPDU filtering on any interface, that interface do not send the BPDU as well as not receive the BPDU. Are you understand, everyone? Clear na? So when you enable the BPDU filtering feature, so what will happen? That interface do not send the BPDU and do not receive the BPDU. Now see na, this is the switch, this is the PC, and on access layer we can configure the BPDU filtering. Yes or no? Yes, we can configure, because see na, on this port, this switch is expecting the BPDU. No, on access port we are not expecting the BPDU. It means not receiving the BPDU. It's fine. Now tell me, this is the switch or end device? End device. So is there any need to switch send the BPDU here? Is there any need? No, no need. So it means this is also fine. So what we can do? We can configure the BPDU filtering on which interface? Access port. On access port, we can configure the BPDU filtering. There is no problem, because on access port, we are not sending the BPDU as well as we are not expecting any BPDU. Are you getting my point, everyone? Yes or no? Yes,
Yes.
na? So that is called BPDU filtering. Clear, everyone? I hope you guys understand each and everything in a very detailed way. Clear?
Yes.